here's the review from the actual practice test that I gave you. And the first several problems are solved any way you like to. So since this one has a y equals, I'm going to solve using substitution. So I got -2 or 2 times -x minus 2 equals -4x. And this we can solve for x the way we would normally solve. Distribute, add 2x to both sides. Divide by -2. And 2 equals x. Y equals negative. Plug in the 2 minus 2. And y turns out to equal -4. Our next problem, I would once again use substitution. I would take my 6. Instead of y, I write down x minus 5 minus x equals 0. Distribute the 6. Combine like terms. 6x minus x is 5x. Minus 30 equals 0. Add the 30 to the other side. 5x equals 30. X equals 6. Y equals 6 minus 5. Y equals 1. In problem number 3, I rewrote the bottom one is x plus 3y equals -1 because I wanted the x's to be lined up and the y's to be lined up. And I'm going to multiply the bottom equation by -2. The reason why I multiply by -2 is because that way the x's will have one +2 and one -2. So minus 6y equals 2. So I got -11y equals 2. Y equals -2/11. Plug that back into the top equation. And so I got 2x plus 10/11 equals 0. Subtract the 10/11. I got 2x equals -10/11. Divide both sides by 2, and x turns out to be -5/11. For this next problem, we once again have a y equals. So I'm going to take this and plug it into where y equals. And so we wind up with 2 parentheses 6x plus 1 minus 15x equals -4. So 12x plus 2 minus 15x equals -4 after I distribute. Combining like terms, 12x and -15x is -3x. And now to get rid of the plus 2, we subtract 2. So 3x equals -6, or x equals 2. Y turns out to equal 6 times 2 plus 1, or 13. For the next one, this is lined up like a substitution problem. So I'm going to multiply the top equation by 2 and the bottom equation by -3 so that I can eliminate the x first. There was no way to avoid multiplying by both equations. So we got -6x minus 15y equals -36. The x's cancel. Negative 19y equals negative 38 divided by negative 19, and y turns out to equal 2. I'm going to plug it into the bottom equation. Not that it matters that much, but they have the positive, so I decided to go with the plus. Subtract 10 on both sides, and 2x equals 2, so x equals 1. Alright, the next one, once again, number 6, I just rewrote this differently because we want the x's and the y's to line up, so this is the x's and y's lined up. So the x's cancel without me having to multiply, so 8y is equal to 24. Divide both sides by 8, and y is equal to 3. So x plus 5 times 3 equals 20.5. X plus 15 equals 20.5. Subtract the 15, and x equals 5.5. Alright, for this one, you need to go to your matrix menu, which is second x negative 1, and you want a 3 by 4 matrix. So go over to edit, make it a 3 by 4, and in the first row, you're going to put 1, negative 2, negative 3 for the numbers in front of x, y, and z, and then 2 is your answer. For the second row, you put in negative 3, 5, 4, and 0, and 1, negative 4, 3, and 14. Now when you have that in your calculator, you want to then quit out of that by hitting second mode. Once you hit second mode, then you want to go back to your matrix menu, move over to math, and go down to RREF. So matrix, math menu, down to letter B, which is RREF. Then you want to go to second matrix and hit A. So basically you're doing RREF of A. And the final column, which is negative 10, 6, and 0, will be your answer because the ones are in diagonal like we talked about in class. So x equals negative 10, y equals 6, z equals 0. For problem number 8, you're going to do the same thing. The top row is negative 1, 2, negative 6, 4, 1, 1, 2, 3 for the middle row, 2, 3, 4, 5. Actually, that should be negative 4. And you want to do RREF of A. And this time you're going to get the answers of 1.5 for x, y is negative 1, z is 1.25. One more of these. We want 1, negative 2, 1, 7, 3, 1, negative 1, 2, 2, 3, 2, 7. RREF of A gives us x equals 2, y equals negative 1, z equals 3. Alright, so this next one, we're doing one of our system of inequalities. So when we graph y equals negative 3, that's going to be the vertical line down here. I'm sorry, horizontal line down here. And we're going to be above this graph, so I'm just going to shade a little bit above it. The next one is x is greater than or equal to negative 2. And so that's my graph down that way. And since I'm greater than, I'm going to be to the right of that. Now for the last one, we have y is less than or equal to, and I'm going to rewrite this as negative 5 halves x plus 7. So 1, 2, 3, 4, 5, 6, 7. That's not even 7. And it says going down 5 over 2. And so if I draw this correctly, this actually kind of connects off the screen. So we're underneath that shading. So I basically have this whole triangle in here. So I want to name the points. So the first point over here, which is the easiest one, is -2, -3. Next easiest one, because it's on my screen, is that right there where I went basically to 4, -3. And the one that is off my screen, I know the x value is -2, and when I plug -2 into this one, it turns out to be at +12. So these are the 3 points in part B that I'm supposed to be using. In part C, now I'm going to use these numbers to figure out what is the best number for f of xy equals 2x minus 5y. So the first thing I'm going to do is I'm going to plug in -2, -3, which is 2 times -2 minus 5 times -3, which turns out to be 11. Then I got 4 -3, so I got 2 times 4 minus 5 times -3, which turns out to be 23 when I put it all together. And -2, 12. Turns out to be 2 times -2 minus 5 times 12, which is -64. So 23 is my maximum and -64 is my minimum. Alright, and now we're going to start the word problem. I know it says bucket brigade on the graph, but ignore that because we don't have a bucket brigade. What happens is Ingrid is starting to plan to start a business. She's going to decorate cakes and pies. So since we're selling cakes and pies, I'm going to make x equals the cakes and y equal the pies. And so she will decorate these. She estimates that the decorating will take 75 minutes to prepare, and a specialty pie will take 30 minutes to prepare. And she plans to work no more than 40 hours per week, and she does not want to make any more than 60 pies in 1 week. So write an equality to represent the amount of time is letter A. So since we're talking about cakes, it takes 75 minutes to make a cake and 30 minutes to make a pie, and that needs to be less than 40 hours, but we're talking about minutes, so I need to multiply that by 60. So really I have 75x plus 30y is less than or equal to 2400. And that's my answer for part A. Now before I go on, I'm going to subtract 75x across the way, because I'm going to have to graph this at some point in time. So 30y is less than or equal to negative 75x plus 2400. And then when I divide by 30, y is less than or equal to, this reduces to negative 5 halves x plus 80. Now in part B it says write an equality for the restriction on the pies Ingrid will be making, and it says Ingrid does not want to make more than 60 pies in 1 week. So my answer for B is simply y has to be less than or equal to 60. I don't know why I wrote 70. And that's my answer for B. And so the next part asks me to graph these inequalities. So the second graph that I started at 80 went down 5 over 2, went down 5 over 2, so the graph looks something like this. So the shaded in region is over here. One of my points is 0, 0. One of my points will be 0, 60. And then I'm going to use the graphing calculator to help me with the other 2 points. One of them will be the intersection. So when I find the intersection, this turns out to be at 860. And the other one, I need to sort of plug in 0. So 80 divided by 5 halves will give me the answer for that next one, and y is 0. So this last point is at 32, 0. The profit equation is $34 for X, and we make $16 for Y. And so when we plug these numbers in, 34 times 0 plus 16 times 0 is 0. 16 times 60 is 960. 34 times 8 plus 60 times 16 turns out to be 1,232. And finally, 34 times 32 plus 0 turns out to be 1,088. So the most profit we can make is $1,232.